All right, our first group of problems asks, polynomial, yes or no, and if yes, what is the degree of the polynomial? Certain rules about polynomials are their exponents have to be positive integers. So most things come from that problem right there. So to start with, number one, f of x is 5x minus 4x cubed. Is that a polynomial? Well, the exponents are both integers. That has an integer of 1, that has an integer of 3. They're both positive. So yes, it is a polynomial, and it has a degree. The degree is always considered the highest power of x, and so the degree is 3. Next one here. This is a constant. This has a degree of 1. It's positive because it's positive 1. So we would say yes, it is a polynomial, and it has a degree of 1. Next, square root of x times square root of x plus 2. Remember that square root of x is the same thing as x to the 1/2. Now, square root of x times square root of x just gives you x, but square root of x times 2 gives you 2 square root of x, which is 2x to the 1/2. So we would say no, it's not a polynomial because non-integer exponents. Non-integer exponents. They're going to ask you why is it not a polynomial. It's because it has non-integer exponents, because square root of x times 2 gives you 2 square root of x. 2 square root of x is the same thing as 2x to the 1/2. No fractional exponents, because we said exponents have to be integers, which means not fractions. All right, this one right here, the reason the answer is no here is because if you have variables in the denominator, that is the same thing as having a negative exponent. And so we would say no, it's not a polynomial because it has negative exponents. Why not? Because negative exponents. They will write the reason, you'll have to choose it. Next, we have x to the 5/3 minus x squared plus 4. Kind of looks normal except for that offending fraction. So we say no, it's not a polynomial because it has non-integer. That doesn't look like integer, but I guess it is. Non-integer exponents. Or it has fractional exponents. This right here, no, not a polynomial because it has negative exponents. All right, let me make sure we can still see. So for my next thing, I'm sorry you couldn't see on some of those what I wrote the answer to be, but let me just scoop this up a little bit. All right, it says find x and y intercepts, okay? To find x intercepts, you let y equal 0. To find y-intercepts, you let x equal 0, okay? So the first one, if you let this be 0, the values of x would make this 0 would be 0 and 3. So it's going to have x-intercepts of 0, that comes from the x to the 4th, and positive 3, that comes from this factor right here. It has y-intercepts. Remember, it has y-intercepts if you let x be 0. So 0 times anything is 0, so it's going to have a y-intercept of 0. All right, next problem. It says f of x is x squared plus 1 times x minus 3 times x plus 1. So it's going to have x-intercepts. Remember, you always take with the opposite thing. But in this case, it's x squared plus 1. Just off to the side here. Let me make sure you can see this on the screen. Yeah, I think you can. If you'd let this be equal to 0, x squared plus 1 equal to 0, then it would be x squared equal to negative 1. And then when you took the square root of both sides, yipes, stripes, you get plus or minus I. So this is not real, which means it's not an x-intercept. So even though it's a 0, plus or minus I, they're not x-intercepts. So this factor does not give us x-intercepts because they're imaginary. But these right here will give us x-intercepts of positive 3 and negative 1. These are the values of x that would make y be 0. Remember, f of x is like y. All right, to find the y-intercepts, all you have to do is you let x be 0. So if you let x be 0, let's just fill in the blanks here. If x was 0, this would be 0 squared plus 1, which is 1, 0 minus 3, which is negative 3, 0 plus 1, which is 1. 1 times negative 3 times 1, I believe, just gives us negative 3. So the y-intercept will be negative 3. Two x-intercepts at 3 and negative 1 has a y-intercept of negative 3. All right, and the next one here is going to have an x-intercept. Remember, it's the values of x that would make f of x be 0 or y be 0. So it's going to be 0. Anytime you have an x squared or an x or x cubed on the outside by itself, the 0 is 0 itself. And then if it's in parentheses, you always take the opposite, so this would be negative 6. Y-intercepts would be when you let x be 0. 0 times anything is going to be 0. If they put x on the outside, the y-intercept is always 0. All right, and last but not least, we'll have x-intercepts on this one of negative 3. It's a double root. Okay, this is a little bit of a trick. X squared minus 16, couldn't they have factored that? Because x squared minus 16 is the same thing as x plus 4, x minus 4. So, so I also have intercepts at negative 4 and positive 4. Okay? So they can't have possibly not have factored it all the way. So look for the difference of two perfect squares, because that will give you two zeros there. So I have those 3 zeros, and for my y-intercept, remember your y-intercept comes from letting x be 0. So that would make this positive 3 times negative 16. Positive 3 times negative 16, I believe, gives us negative 48. So it's going to cross the y-axis at negative 48.